Thursday, we started graphing some basic functions. We said the first one is the linear function f of x equals x. Does anybody remember how we graph f of x equals x or y equals x?
That is a line.
This graph is a straight line going through the origin, right? Okay. We didn't talk about this last time, but just to complete the discussion, so what is the domain and the range of the linear function? You know the graph. Domain is what? From here to there is what? All real numbers, right? Okay, Madeline, what about the range? Also all reals, right? Because the line, remember the line extends in both directions. Okay, so that is your linear function if you want to make the arrows. Okay, so just indicate that it will extend all the way. Quadratic function we said is a degree 2 function. This is the basic quadratic function. How will this graph? Parabola, where is the vertex of this parabola? 0, 0, right? And then it opens up, right? So we played with this last time. Okay, again, if you want to examine the domain and the range of this, what's the domain of the basic quadratic function? The domain is all real numbers. What about the range? Oh, this is not straight edge. So the range is where? From 0 to infinity. Okay? Positive infinity. Okay. We also looked at the cubic function, the basic cubic function, f of x equals x cubed. Does anybody remember the shape of this? It's kind of like an S, right? Okay, so
it's a curve.
it's like this and it's curving like that, okay? And it will extend in both directions. So that's your cubic function, and we said that the domain, well, if we look at this, the domain is what? All reals, right? And what about the range? Again, all reals. Clear? Okay? So we did those three. So to start the week, maybe we can do a warm-up. Of course, then you will see this in your variations of this. So here, do you see what basic graph I need for this? When you see this, let's say in your final,
It's a parabola.
you see that this is a parabola because what do you see?
Square
You have f of
square.
x equals x squared, right? Okay? So this is your parabola, f of x equals x squared. What happened to the parabola? It got translated or shifted how? It got shifted 2 units where? So this means you move it 2 to the right? Right? And this 3 means what? You move that basic parabola how many? 3 units up, right? So you have that parabola. Basic was this, right? You move it 2 units to the right, okay? 3 units up. So therefore your new parabola is this. Also notice there's no number here, it's 1. We explained last time that depending on what number is sitting here, it will determine the width of the parabola, right? But because it's just 1, that means to say it's this exact same parabola, you move up and to the right, okay? So that's your translation. You can review that, okay? Like if I put the number here. How about this, example 2? What basic graph do you see here? Graph g of x equals x plus 1, the quantity cubed. So which one is this? This is a cubic function, right? The basic function is x cubed, right? G of x equals x cubed. But then what did I do with the graph? How will I graph this easily if I know the basic graph of the cubic function?
Move it 1 to the
This
left.
means I move this, Elliot, 1 where?
To the left.
1 to the left, okay? So you can start with your basic graph. Move, the basic graph was here, right? Okay? Move this all 1 to the left, so everything will move 1 to the left, 1 to the left, okay? So therefore your new graph will be this. You guys understand? Alright? So that's what we have there. Okay. Then notice when you do some shifting, like for this one, the domain and the range of this red graph will just be what? It will change also. What's the domain of this? Well, the domain won't change because the domain will run from left to right. So it's again all real numbers. What about the range? Starts from where?
3.
What is that number? 3, right? Okay, it will start from 3 and will go all the way to are you okay with that? That was what happened last Thursday, okay. Let's continue graphing our basic functions, okay. The other one, well, so now you know, like these guys, you have x to the 1, x squared, x cubed, then you can also graph what? X to the 4th, x to the 5th, but since we don't have time, it's last week of the semester, I leave that up to your college algebra instructor to teach you how to do that. Okay, so we go all the way to cube, okay? And then now the next thing I want to show you is, what is this? This is the square root function. What do you think the equation of the basic square root function will look like? F of x equals what? Then done. Square root of x, right?
It's going to be like
Half you know, okay, good.
Thank you, Walter.
Dan already knows what it will look like. It will be half a parabola. According to Dana, this is going to be half a parabola. How did you know that, Dana? And what kind of parabola will it be? F of x equals square root of x. Well, if you didn't
it's
see
not going to be a negative.
if you did see that, actually Dana said something, it cannot be negative. Well, remember we talked about domain, right? Okay. If this is x, what numbers for x can be assigned? Only because it's inside a radical
Only
sign.
positive numbers.
Only positive or
0.
0, right? In fact, let's do a t chart, okay? I can assign 0. So the square root of 0 is what? Square root of 0? 0, okay? What other number can I assign? 1. Square root of 1 is 1. Do you want to continue? Do you want to? No. What's the next number that's nice?
2, 2.
4, right? What's the square root of 4?
2.
2. Let's look at these points. So I have 0, 0, 1, 1. Oh, sorry. 3. 4 will go to 2. You guys see that? Okay. So therefore, your basic square root function will look like this. And it's half the parabola, the half of the parabola that was what? Facing sideways. Okay? So that's what Dana said. It's going to be half your parabola. And notice there's nothing here because you cannot take the square root of a negative number, right? Okay? Also, there's nothing down here because the square root of a positive number is always going to be positive or 0. Okay? So actually with that, we see from the graph that what is the domain? 0. The domain, Myrna, is from 0 to positive infinity, right? And what about the range? There's nothing here, right? There's nothing here. So again, it also starts from 0 to, then it keeps going positive infinity. Very good. Okay? And again, we can play with these guys. Be okay, Walter? Just a little example. What is the effect of the +3 inside the square root sign?
That's going to make it 3 to the
We'll move the
left.
graph 3, where? Left, right?
Left.
Left, right? Left, right. Okay. It will go 3 left, alright? And if I put, let's say, a -2 here, what will the effect of that be? 2 to the, no, outside of the
Oh,
square root.
outside?
It's outside
Down.
of the square root.
Down.
2 down. Okay? So let's try doing that. So I know that from that part of the board, the basic square root function looks like this, right? Okay? What will I do with this basic square root function? I move this graph where? 3 to the left. So I move there, right? And then I go down 2. So basically, you can think of it as you move your axis here. That's another way of looking at this, is you move your x-axis down below, right? And you move your y-axis here, okay? You can call this x prime, y prime. If that's another way of doing the thing, okay? So this black basic graph will now start where? Do you see it? It will be here, right? Okay? It will be here and it's going to be translated. I mean, it's not quite accurate, but yeah, if you want to be more accurate, you can get some points. But this will go down here, everything else will move, okay? Did you guys understand? Okay, that's how you understand. Alright, where should I write my next ones? That's number 4. Let's just continue our basic functions. Okay? I have f of x equals square root of x. I also have the basic reciprocal function. What do you think the reciprocal function will look like? Reciprocal. It's division, right, of what? If you have a number x, what is the reciprocal of a number x, Ross? 1, not 1x, 1 over x, okay? So the basic reciprocal function is f of x equals 1 over x, reciprocal, right? Let's see, let's try to graph this. How do you think we can graph this? You want some table? Or can we just talk about it, or do you want to see the chart? Chart, all right. Said Alexia, why don't we see this visual, right? Okay. Well, what numbers may I assign here? You have 1 over x over, you already know right away there's a flag that's being raised. Can you assign, what number may you not assign?
0.
0, right? So you cannot assign 0, so actually you know that you cannot go here, right? X cannot be 0. So therefore, we can assign, what's the next number that's nice, other than 0? 1, okay? If x is 1, what is the reciprocal of 1? What's 1 over 1? 1, right? Okay, so there you have a point, 1, 1. Okay? What's the next number that's nice? 2, alright? If you have 2, what happens? You will get 1 over 2 or what? A half, right? 1 over 2 is a half, so when you have 2, you go to a half, half is lower, right? What do you think will happen? As I keep assigning bigger numbers like 3, what will happen? This will be 1/3, so what will happen to these points? They will become lower, right? Not small, lower, correct? Okay? They will become lower and lower, and what's happening? What's happened here? If I connect these points, what will happen? Lower and lower, lower. Will it ever cross the x-axis? No. Will it go down?
No.
Because
you're not assigning 0.
no, it's not because you're not assigning 0. If you keep assigning big numbers like 1,000, right? What will happen? What's the reciprocal of 1,000? 1 over 1,000, which is a very small number. What I'm saying is, will this y value ever become really 0? Will it hit this?
No.
No. Okay? Do you remember what that's called when you hit a line, when we approach a line but you never really actually touch it? You will have what you call an what? Starts with a sim.
Oh.
Okay. Okay. Asymptote. Remember that? So that will be an asymptote. Okay. The story is not quite finished yet. Why is it not finished? What else may I examine also? Well, we have these. Let me continue my chart here. Well, what happens here, you think? Let's look at what happens here. What's a number between 0 and 1 that we can assign? Let's say a half, right? Halfway between 0 and 1, let's see what happens. If x is a half, what is 1 over x? What's the reciprocal of 1 over 2?
2.
2 over 1, which is 2, right? Okay? So when x is a half, you get 2, so you have this. Again, hopefully you see what happens if I put a third, which is smaller than a half. What happens? The reciprocal of a third is what? 3 over 1, which is 3, right? So do you have an aha that, oh, okay, I think what will happen? What should I do here if I were to draw this? What should I do? If I connect, again, what's this scenario? Connect, then what? Will I ever cross the y-axis?
No.
No, we just said that earlier, right? X cannot be 0 and the y-axis x is 0. So again, we have an asymptote right here, okay? Alright, did you understand what happened? We assigned, and we're looking at the shape of the reciprocal function. Do you think we're done? Why not, Julio? But I guess we have to examine what's happening on the other side, right? Okay, what's happening on the other side? And maybe we can do away with the chart this time. If you have x is -1, what is the reciprocal of -1? -1, right? Okay. So the reciprocal of negative 1 is negative 1. If x is negative 2, what is the reciprocal of negative 2? Negative 1/2, right? Where should I draw negative 1/2? Here it is, right? Okay, and so there. Okay, so again, you see what's going to happen on this end?
Same thing, just.
Same thing, Dana, except which same thing? Same thing as which portion here? This or this? It's kind of like this, but now it's going where? Like this, right? To the negative. Okay? What do you think is going to happen here? Candy said, okay, I think we can just keep going down. Will I hit the y-axis? No. All right, very good. So that is the basic shape of the shape of the basic reciprocal function. All right. Again, if we look at the graph, we can examine or analyze the domain and the range. Okay. Anybody want to help me with the domain? Do we hit everything?
No.
Which one don't we touch? The 0, the y-axis, right? So in fact, we saw that as early as here, right? So how did we write that a long time ago? We are okay with every real number except for what number? 0. And you can write it in words, right? All reals except 0. What about the range? Huh? All real numbers except, again, because we didn't touch this, except 0. Same thing. Okay? You want to move this around? Let's just play one game, okay? Let's move it. If I put f of x equals 1 over x minus 1, what does that mean? The minus 1 under with the x means move 1 where? If you mess up the x, does it change up, down, or left, right?
Left, right.
Left, right, right? In particular, Alan, this means what?
You go right.
1 right. Okay? Let's just do that. If I put a number here, or don't do it now, do it later. So just move everybody 1 right. So what will the purple graph look like? This, move this 1 right. This, move this 1 to the right. Everybody gets moved 1 to the right, right? 1 to the right. So it's basically like this. It's not perfect, okay? The red graph moved like that. All right, okay? Actually, yeah, I can explain this better. If you move it 1 to the right, the 1 is not going to figure, right? Because x cannot be 1 here. So the new asymptote will actually be x equals 1. But very roughly, that's what's going to happen. All right? Same thing with these guys. You move all these points 1 to the right. So this will actually go here. This will go here. Okay? You get it? And everything will move. So what happens is, again, this is the asymptote. And you have something like that. Did you guys understand it? Okay? So kind of just training for your eyes to see, okay, if I see the basic graph, which is 1 over x, I can just move things around. All right. What else do I have? What other function did I talk about? Did I talk of absolute value in the book? Take a break. Suddenly I got back. For this course that I'm going to talk about before I go to the big chapter that next, okay, is the absolute value function. What do you think the basic function will look like? F of x equals what? Absolute value of x. We did this a while ago. Do you guys, does anybody remember the shape of the absolute value graph? Dana said we did this a while ago. It's V-shaped, right? Well, let's review. Why is it going to be V-shaped? When you put a 0 there, what happens? Absolute value of 0 is what? Absolute value of 0 is 0. If I put a 1 in the x, absolute value of 1 is 1. If I put a negative 1 in the x, what's the absolute value of negative 1? Absolute value? Positive 1, right? Don't be afraid. Okay. So do you see the V shape now, or do I need to do some more? you have 2, then it will go to where? To 2, right? If I have negative 2, I'll go to 2. Guys, get it? Okay? So this is, well, I've been using red. So this is your basic graph. It's V-shaped, right? Okay. That is your basic absolute value function. What's the domain of the basic absolute value function? Domain? All real numbers. What's the range of the basic absolute value function? From 0 to infinity. Alright? Let's just play one game. So if I have, let's say, g of x is equal to the absolute value of x plus 2. What does that mean? How do I move this red graph?
Left,
Is it left?
No, to the right.
right?
Where would it be left, Alan? If I had put the plus 2 where?
Inside.
If I had put the plus 2 inside, right? Okay. If you had a plus 2 here, that means 2 left. But that's not what I have. I have absolute value of x plus 2, so this means that I have to move the graph to where? Up. Because it's the answer that you're changing. It's the y you're adding to all your y answers, right? Okay. Did you guys see the difference? Okay. Here it's the x you're changing. You're moving x to x plus 2, so you're moving it to the left. Here you're moving this 2 up. So therefore the purple graph will look like what? Everybody gets moved up. 2, 1, 2, 2. Move up every point, 2, okay? So your purple graph will look like this. Sorry, sloppy. Alright? So for the purple, what's the domain and the range of the purple graph? The domain is what? Did the domain change? The domain is still all real numbers from negative infinity to infinity. And what about the range? From 2 to infinity. Did you guys understand what hit us? So we have the 6 graphs. Okay, 1, 2, 3, 4, 5, 6. Hopefully, if you move on to another math class, you'll see these guys and you'll know the shape. Basically, that's the goal here, is that you don't draw a line when there's a parabola, right? You don't draw a V shape when you have cube, and so on and so forth. All right? Any questions?